Now I'm going to talk about accessory organs of the digestive tract. Remember that accessory implies any organ outside of the GI tract itself. All right, so the liver is in the abdomen, of course. It's a very large organ with 4 lobes, 2 major lobes and then 2 smaller lobes. You've learned about liver anatomy in lab. And the job, one of many jobs of the liver, is to produce bile. The liver is not just a digestive organ. It is a chemical warehouse, powerhouse. It is able to build molecules, so it's able to take monomers and use them to build polymers. Also able to do the opposite, so it's able to take polymers out of storage and reduce them back to monomers to be released into the blood. But for digestive functions, your liver produces bile, which is a liquid substance that includes byproducts from the breakdown of hemoglobin. But the digestive function of bile is to emulsify fats. By emulsify, we mean taking larger fat droplets and breaking them into smaller fat droplets. This is mechanical digestion, meaning no chemical bonds are broken. The purpose of bile is to make sure that we have small enough fat droplets that once we start to enzymatically break down fats, those enzymes have plenty of surface area access to those fats because smaller particles of fat have greater surface area compared to volume than larger pieces of fat. Another thing that the liver does is it creates some of the blood plasma proteins such as albumin, which isn't particularly a digestive function. The liver also stores nutrients, such as glucose is stored in a form called glycogen, as well as iron and a variety of other nutrients are stored in the liver. And finally, the liver does perform a filtration function on the blood. You might recall in lab you learned about the hepatic portal system. Remember that all blood coming from, say, the spleen, pancreas, small intestine, large intestine, stomach, all of that blood goes through the liver, through the portal vein, so that the liver can adjust that blood chemically and also detoxify that blood. Attached to the liver is a separate organ called the gallbladder, and the gallbladder's job is to store and concentrate bile. It does not make bile, but it does store it and concentrate it for when it's needed. Bile is a fluid that is yellowish green due to the chemical breakdown of the heme part of hemoglobin. You also find in bile acids, cholesterol, and a variety of pigments and phospholipids. The bile acids or salts are the ones that actually do the emulsification of fats. And the pigment, the primary pigment in bile, is bilirubin, which again is from the breakdown of the heme in hemoglobin. Ultimately, that bilirubin is to be removed from the body, so that's why we're putting it into the GI tract. And although it's greenish in the gallbladder and liver, and it's greenish in the small intestine, by the time that bilirubin goes all the way through the colon, bacteria will have converted the bilirubin to urobilinogen, which is kind of the final phase of that pigment breakdown. And that's what gives the brown color to feces. So really all of the colors in the body are due to the breakdown of the heme molecule, all the way from the bright red of oxygenated blood to the yellow in urine, to the green in bile, to the brown in feces. It's all related to that same heme group. All right, the pancreas is another accessory organ. It lies just inferior to the stomach, and its job is both endocrine and exocrine. As an endocrine organ, you know that it produces insulin and glucagon for regulation of blood sugar levels. But as a digestive organ, it's an exocrine gland, meaning it secretes digestive enzymes through a duct. And those digestive enzymes are varied. Your pancreas can digest just about anything. It produces a variety of enzymes that we'll talk more about in a later lecture. But essentially, the enzymes from the pancreas can digest proteins, lipids, nucleic acids, and carbohydrates. So a wide range of digestive enzymes. Your pancreas also secretes water as part of the pancreatic juice that it secretes, and then also a pH buffer called bicarbonate, which helps to neutralize the acids coming out of the stomach and into the duodenum. If you note the location of the pancreas, it's got a duct that feeds directly into the duodenum. Its duct merges with the common bile duct, and both the pancreas and the common bile duct feed into the duodenum at the same point.